Hi, dear students. This video is to demonstrate how the model of a vehicle tire is created in Inventor. Well, I have few slides to remind you saying tire we mean what. Watch the video, watch the presentation first, and then focus your attention to the Inventor environment. Okay. Yes, tires. Well, there is a photo here. There is an offshore off-road vehicle. Okay, and here this part tire with the pattern over the rim of the wheel tire. Okay. Well, actually, in my demonstration, I want to answer how such a pattern, okay, surface texture is created over the say the rim of a tire. Well, depending on the season, summer season tire, winter season tire, all seasons tire. Well, and also the speed of the car. Well, the pattern is determined in shape and in size. Okay, by the designers. And then here I'm going to answer the question, not how this pattern is say size and shape, no, but how it is created, because the pattern, the geometry of the pattern to determine its shape and size, well, it is an application field in well, partially fluid mechanics, partially deformable bodies mechanics, dynamics. Okay, well, when you be third year or senior student, you may take an elective course, well, just to the point about the tires, you can learn the details. But here my demonstration assume that the profile pattern has been determined by designer, and how about the rest, how the model of the tire is created. Actually, the tire, the main part of tire is a composite object. Composite material is a composite material. Well, from this partially broken model can see the layers: thread, protector ply, under thread, belt plies, casing plies, and then just along this edge it is to be mated to the rim of the tire. We have chamfer rubber bead. Okay, it is really a technology, special technology, well, manufacturing technology, and well, it is not a simple object. Well, it is geometry special, especially the size and shape of the threads on the rim. The pattern, this pattern is special, and the material is a composite material. Actually, to be able to create the real model, say the model of the tire as if real, then have all the layers in the model. But here I'm going to make a simplification, assume that as if there were only one layer. And then to be able to create the model of the tire, yes, start from here. Well, at the cross section of the tire, see what is the shape, what is the size. And then draw this figures. It is just the cross section of the tire. Okay, and then, well, you know where is the center, where is the longitudinal axis. Okay, in sketch mode, draw that axis, and then showing the region, so showing this profile as the region, apply revolve process. Then this means you created the main part of the tire. And then the rest is thread creation stage. Well, this is the rim of a tire, and this is the tire assembly. Well, we have rim, wheel rim, and the tire. Okay. Now, then after this very brief info, or just reminding purpose, just a short presentation, scrolling the pages of such a short presentation, then, well, see the CAD application. Actually, well, I have already created the model of a tire, okay, applying revolve process, and also have a look at, see the pattern over the surface, okay, threads of the tire. Of course, I simplified the threads in shape, okay, but say the method is the same, not a matter it is in such a simple configuration or very complex. The thing to do is the same. Okay, now see, start from the beginning. Well, in sketch mode, well, I had the profile saying that at the cross section of the tire, that is the geometry, that is the size. Okay, in sketch mode, using the tools of Inventor, and you know, in Inventor the only method to apply is the modern method. Well, in the end I had this profile. Okay, well, this profile in my short presentation corresponds to this one, such a one. Okay, but here at this stage, well, in the sketch there is no in the region there is no thread yet. Okay, have a look at, you see I have no thread the projection of the thread in the sketch. Assume as if the rim were a continuous surface without any thread. And here in the sketch there is one more thing, this line. Okay, I'm going to show this line. It is the line to be shown as the axis of revolving. Depending on the diameter of the tire, yes, well, input this dimensional constraint from the tip to the axis of revolving. Distance is 410 millimeters in this example. And then finish the sketching stage and then apply revolve process. Yes. Edit feature. Yes. Showing the profile. That profile. And in the order thereafter the axis. And of course selecting the angle of revolving as 360 degrees. Okay, 360 had the model of the main part. Okay, and then the rest. Well, embossing stage. First I had a work plane. Yes, using the work plane invoking tool of Inventor, I selected offset from plane, and then at this stage I indicated the coordinate plane, this coordinate plane as the reference for having that parallel work plane. This is the reference which I indicated, dropping the list of the coordinate axes here, coordinate planes here, and then, well, indicated one of them as the reference. I indicated YZ plane as the reference for having that parallel work plane. Okay, after having the work plane, I took a ride over the work plane. Okay, and then, well, as the sketch, see the sketching stage, as the sketch, of course here I simplified the geometry of the threads pattern for having the pattern. Okay, it is in this form. Well, straight one and then inclined ones, where over the sketch plane in sketch mode I drafted those, and of course size and shape. Okay, inputting the constraints. And after finishing this say sketching stage, yes, apply embossing process. Where is the push button to start the process? Here it is in creation panel. It is written emboss. Okay, see the dialog box at this stage, edit feature. Yes, at the end of the sketching stage, over the work plane, yes, what is that? Well, as the visibility of the work plane. Okay, right click and select visibility option. Where is the visibility option? Here it is. Okay, and then, well, the sketch is over this work plane. Edit sketch. Yes, over this work plane, I have the sketch plane. Taking a sketch right over this work plane, I coincided the sketch plane of the sketch, and, well, over there, relative to the projection of the edge of the tire, the main body of the tire, well, I located this profiles. Okay, and then finish the sketching stage, and followingly apply embossing process, emboss. Well, at the beginning of the embossing stage, yes, clicking on this button, I started the embossing process. Well, I selected this option, cutting option. Okay, and then saying that into this box wrote the cutting depth in the radial direction, it is measured relative to the outer surface of the tire. I wrote well, 2 millimeters, and then, well, indicated the profile, saying click on profile button. Actually, it is done by the software. Indicate this and that as the region, as the profile, and that is it. Thereafter, I said that well, the red arrow to its sense is important. It is to be toward the tire, toward the rim of the tire. Okay, if the direction of this red arrow is wrong, then flip-flop, reverse it. Okay, you see arrow is over there. It must be from the work plane where we have the sketch toward the rim of the tire. This direction is correct. And then, yes, I said okay. After having the created grooves in the rim of the tire using only 3 of the threads, then I apply array copy process. Well, said that polar array, yes, as the feature, you know, the selected button is feature indication button. I indicated the already created grooves, this and that, okay, as the feature to repeat. And, well, in this example, I said that 30 sets are over the rim of the tire. Okay, and the for the array copy process, well, the members of the family, the distribution angle is 360. Okay, and then clicking on axis indication button, I indicated the edge of the tire for saying that it is longitudinal axis is the axis of distribution. Okay, and then created the copies, saying just okay. Of course, after having the tire with the pattern or thread over its rim via using a work plane at this stage. Well, the good practice is that no need to keep this work plane in the domain, so take it as visibility. How? Bring the cursor to the browser. Over there, find work plane icon, right click the mouse, and this menu will drop. From the menu, making a click, deselect visibility option. That is it. This is the tire. Of course, well, this tire, the model of the tire is for assembling to the wheel rim, and then wheel rim to be assembled to the rest of the car, etc. Of course, the rest depends on your interest. You may continue if you want, but here my demonstration, I think, became clear enough. Here is the model of tire. Thereafter, of course, after creating the model, input the material saying that kind of rubber. I selected rubber, okay, to make it more realistic. Okay, I think you understood what I mean and learn how the model of a tire can be created in Inventor. Okay, my dear students, have a break. After the break, I'm going to talk about Archimedes screw, how it is created. Answer this question. These are not the CAD part of the chapters. These are complementary presentations, complementary demos. Just specific how the pattern of on the rim of a tire is created, how a propeller, the model of a propeller is created, and the next video record I'm going to answer such a question: what is Archimedes screw, how it is used, and how it is created. How is the model of an Archimedes screw created? I'm going to answer those questions in the following video record. See you then. Bye bye.